Hey there guys, this is Aaron. I am here to do a quick tutorial video on functions, and we're going to run through this really fast. You can watch it over and over if you need to get better explanations on things, but effectively a function has three parts. There's only two you really need to remember. It's the prototypes up here, above and outside of int main. These are separate functions, right? And then the definitions are down here. And they've got little plus and minus boxes here you can use to collapse them like that, okay? So once you have, we should probably do a quick explanation of what prototypes are and why they exist. You can see right here I have int num equals 5, and then I'm printing it out. This works. But if I move the declaration and definition beneath it, it doesn't work anymore because we read code top to bottom. So to prevent us from having to put all these big old definitions right here above our int main, it'd just be really irritating for us to have to scroll all the way to the bottom to start working on our code, especially when you have thousands of lines of code. So we put these prototypes up here, and this tells the computer, okay, you called printHelloWorld here. There's not a definition up here, but there is a prototype. So I'm going to look below int main. Is there a definition down here? Ah, there is. Here it is. So it tells the computer that somewhere in the computer program there is a definition of this exact function, and all the computer has to do is go look for it. So the way a function works is it's kind of like a recipe for making a cake, where you have arguments, which would be ingredients, that the function is able to put together and print out and add and total and return and all that stuff, and at the end you have a cake. So when thinking about arguments, as you can see up at the top of this window here, we have the printHelloWorld function with no arguments in the parentheses. That's like a pre-mixed cake. You dump it all into a bowl and bake it, and all of a sudden, boom, you've got a cake. Another one, like the printMyMessage one that has a string, an integer, and another integer, that's like ingredients that it doesn't already have inside. It needs you to give it those ingredients for it to be able to do anything like making a cake for you. So just to clarify what an argument is, the arguments go here inside these parentheses when we do a function call. Right here in the prototype, we're listing the data type of the arguments we're going to use. So if I want to put a string as the first argument, I have to put string here in the prototype. If I want to have the next one to be an integer, I have to put an integer here. And when we go down to our definition, when I look at the arguments here, you can see these words next to it. These are variable names that will be used inside the function body, here, and only inside the function body. So there will not be a string called message outside of this function right here. I can't use message up inside this one without declaring another variable in here called message. These are all self-contained within this function body. So you can see we've got the int number, sum of two numbers, and this works in the same way that we use this right here. So I have declared a data type, declared a name for the data type, right? There's a name for the variable name, excuse me. And then instead of setting equal to 19, whenever we call this function, so print pretty message is what I'm looking at here. When I put a string here, right? We said the first data type is a string. What I'm doing is setting message equal to this string right here. And then num, which was declared up here, right there, num19. I'm setting number is equal to 19, equal to whatever value we put inside. So the arguments are things that we put inside the parentheses and that the function body right here uses to do stuff for us. So let's start from the beginning with a very simple one. printHelloWorld. So here we know what this is going to do. It's going to see out a string called the hello world and then inline. And it doesn't have a return anything, so print hello world doesn't actually equal anything. It's just going to do the code inside. This doesn't have a value, it's just code. So it's going to do that and then nothing else. And we do the function call down here by just typing the name of the function with the parentheses. There are no arguments for this function. It is just plain old-fashioned function right there. We go to the next one here. We have another void. This is the return data type. It's not returning anything. Take a look at the definition. And this one's going to print out a message. And we don't know what the message is because we haven't given it an argument yet. This is an argument. In the definition, we have to give the argument a data type. And if we want to add more, it's comma, data type, right? That's how we add arguments to these things. Keep in mind that the prototype up here and the definition at the bottom has to match. They cannot be different. Whatever we put here in the parentheses is going to be given. So we put, I like you just the way you are. It's a famous Mr. Rogers quote because he's wonderful. If we hover the mouse over the function name, it will show us the arguments required to make the function work. So as you can see here, we have a string variable that will be given a name message inside the function. So whatever we put in the parentheses, I like you just the way you are, will be given to that message variable. Now here I have a few cout statements. And the purpose of these cout statements is to show you how you can use a function call like a variable. Rather, how you can use a function call with a return type. So what a return type does is it actually turns a function call with arguments inside into a value. So you can set it equal to something, you can add it to something, you can print it out. So here you can see I have a string function that has the local variable named the word, and whatever I put inside those parentheses is going to be given to the word variable and then returned, making that entire function call literally a string. So I have the word here with a period in quotation marks, right? It's going to go into the word, local variable inside the function, and then it's going to return the word to that function call. So if it says I want to print a single word outright, and then here, it's going to work as if it was a string variable that I put a word into and then print it out. The only difference between this and an actual variable is as soon as this line of code right here is over, that value disappears. These will not store values unless it's a static value inside of the function, which we're not really going to talk about that right here. That's something we'll do a little bit later if we need to. Then we have another one I'm using kind of as a variable. So this is cout, the sum of two numbers is, and I have a function here called add two numbers together with the two numbers in here. So what it does is I have a local variable declared up here called num1 and num2. And inside I declare a new local variable called total because this is not an argument, right? I don't know what the total is going to be before I start this process off. So I'm not going to declare it as an argument up top. Oh, I'm going to take this jacket off, but I'm all tangled now. Okay, so it's going to take the new local variable total and add num1 and num2 together and set it to that, and then return that total. So this right here equals a number because it's an integer. The return type is an integer. These words will become an integer at the end of this function, right? Whatever I return. So this whole thing becomes total. So the sum of two numbers is 15 plus 30 is 45. This whole piece right here becomes the number 45. That's what a return type is. It kind of turns the function words and the arguments inside the parentheses into one value. And it's important to note that you can only do this one time with each function. You can use reference variables inside of a function to change multiple variables outside of it. That's okay to do, but if you have like the words here for this function and the arguments, this part at least can only be one thing. It can only be the data type that we set at the beginning, which is an integer. Then just to kind of show you the power of these functions, I have void print pretty message, and I've got it right here. The first argument is a string. The second argument is an int, and the third argument is an int. So these are things I have to know. I have to know what these values are before I call the function and give those arguments to the function so it can work. So here I have print pretty message. It has a local variable called message, a local variable called number, and another local variable called set of two numbers, or a sum of two numbers, excuse me. So it's going to print out the message, and here's the message I have. This is an example of the power of functions. Then it's going to print out the value of the num variable is, and whatever I put for number, which is num, right? And then the value that adding two numbers together function totaled up is sum of two numbers. If that was confusing at all, I have a variable called num here that I initialized at 5. It's going to use the number 5 and add two numbers together. 5 plus 19 is 24. It's going to use the number 24. And this is a string. This is a value, this is a value, and this is a value. Technically a string, but a value nonetheless. And we give all these arguments to the function, and it just uses them inside its own code here. So it uses a local variable called message that we stored this in, uses number, which we stored num in, and it uses sum of two numbers, which we used add two numbers together. We actually used this function call like a variable because we can do that as long as we give it arguments. It has a return type. It is an integer, just like the int down here we need. So I wanted to give a better visual of what's going on whenever we do our function call here. You can see that we have the arguments up in the function call above the little blue box, print pretty message. And down in the black box at the bottom of the screen, I have two examples of kind of what's happening here. It's taking the local variable inside the function called message, and it is applying the value that we passed into it, like as you see there, message is equal to this. The same with the number. It's giving it the value of the argument we're feeding into the function call. Sum of two numbers is being fed the value of another function call, which has a return type, so it has value. I just wanted to give this visual representation to help make a little more sense on what is actually happening when we do a function call. Okay, so that's the basics of functions. You make your prototype, make sure it has the data type for the return value if you're going to return one, arguments if you're going to use arguments, and then you make your definition down here, and then you just call it whenever you need it. You can call it no times, you can call it 1,000 times. Functions can be used over and over again with the same format. Now let's do one with a reference variable. Okay. Let's see. Let's call this one. We're gonna make it a void. Call it change the value of pi, and not pi like an actual pi. So we're going to create a definition, quick actions and refactorings. Okay. Now to make a reference variable, we have to declare a reference variable that we're going to use, and I'm going to make pi an integer, right? So int ampersand, this declares a reference variable. I need to give it a name down here in the video. And I got to give it a name for the reference variable. So we're going to call it pi, right? So whatever we put inside of our function call as an argument is going to be given to this local variable pi. And we just say pi equals 5. So, I mean, that's really simple. I don't need to return anything else. So now I'm going to declare a bunch of these with different numbers. So go 2, 3, 4, 5, 7, 89, 25, 45. Change this one to 19. Okay, every single one of these has a different value. None of them are 5, right? But we're going to plug them all into this function right here. So I'm going to take the name, give it some parentheses. Now it's going to give me an error message here because it wants an argument. Because I have a prototype up here with change the value of pi and a single argument. I can't call this without having that argument. So if I hover over the name, you see this little box pops up and it says change the value of pi int ampersand pi. This tells us the data type of the local variable argument that we need. And this is the name it will be given in the definition. So whatever we put in here, let's put num. Okay. Num is 19, right? We'll bring num in here. And what this does is it redefines rather, num equals 5 because num is equal to pi is equal to 5, therefore num is equal to 5, right? Then I'm going to call it again. I'm going to call it for each one of these numbers, right? Let me close this definition. It's making it confusing. Yeah, there we go. Okay. All right, so we got num 2, 3, 4, and 5. So these are all variables, all different crazy things. But if I'm calling them in here, I'm saying num5 is equal to pi is equal to 5. Num5 is equal to 5. And what this reference variable allows us to do, even though we're not returning a value here, we're not saying outside num5 is equal to change the value of pi num5. We're just calling this. The reference variable is not a value, right? It's not putting the number, if we're using num5 here, it's not putting the number 45 in these parentheses here. It's putting the variable num5 in the parentheses here. A reference variable references a location where the data is stored, not the value inside of that location. So we're going to change the value inside of this location by saying pi, and by extension, num5 is equal to 5. Num4 is equal to pi is equal to 5. So now if I print all these out, go num 2, 3, 4, 5. Yes, there we go. And yeah, then inline. Now when I print this, I shouldn't see 19, 7, 89, 25, and 45. What I should see is 5 for all of these, because these function calls took in the location and then changed them all to 5. Let's try it. It's going to have a whole bunch of other stuff. We should see 5, 5, 5, 5. Oh, what is this? No, get that out of here. I don't know what that little mistake was. Oh, okay. These up here got uncommented somehow. There we go. Five, 5, 5, 5, 5. And then, do we have another 5 printed below that? Yeah, num right there, 5. Cool. So that's what a reference variable does. You can use strings for that, doubles for that. Remember that whenever you use this ampersand, if you put a variable name in here, it's going to change the contents of the variable. You're not putting in like the value of a number, you're putting in literally the variable name. That's the only difference there with those. I think that's about it, man. I hope I kept that short and concise enough. If you need, what I can do, actually, I can upload this for you whenever I do this video, and you can actually look at this and see how they work and play around with it, and hopefully that will help you get it. All right, guys, have a great one. Thanks much.